So I want to start by asking a question. How many people in your organization are getting the question, how are we going to implement AI? Comes up? Everyone got ready answers? Just piece of cake, right?
We're going to do it badly, we're going to stumble over our feet, and then we're going to iterate it, and then we're going to pilot, and then we'll figure out what to do.
Yeah, we can be agile and trip our way through in that form of agile, right? Yeah. Okay. So how do we do it? And guess what? One of the most important things we need to do to make this work is proper old school KM. And that's the message we're going to give here, is that KM enables what we call knowledge artificial intelligence. So let's get started with the problem definition, right? We've all got all this great knowledge and information in our heads. And we're great at answering questions. If you have an issue, who do I ask, right? Where do I go for answers? That's how we do it today. But now, when people are talking about AI, they're talking about Alexa, right? They're talking about, how can I ask Alexa something and get the right answer back, right? How can I have systems that tell me what to do without me having to ask, that know what I want when I want it, right? So that vision of how do we move from that person to the system starting to answer questions. That's a big leap, but it looks really cool when people do it, right? And anyone heard about knowledge graphs? You know that's the foundation behind Alexa, Google Home, and your cell phone. Right? When I ask my cell phone a question, that's knowledge graphs. And in fact, one of the things I want to do, because I've been burned by this the last time I gave a similar speech, I'm going to turn on Do Not Disturb. Because last time I was doing this, I talked about Google. I have an Android phone. And the phone said, "Okay, Google, what do you want, Joe?" Mid-talk, so let's try to avoid that. So let's talk about how we go from our current state to that future state of machines answering questions. And as we think about that, the first thing you need to keep in mind is different types of information. We're all in KM, so you all know tacit versus explicit information, right? Tacit is that which is in your head. That's those people that have been with the military. I know you're from the military. They've been with the military for 30 years, right? How much do they know? It's crazy, right? Just incredible information. But what can you do with that? Not a lot. You've got to pull it out, right? So how do we get that out of them? But only the good stuff. So a little bit of background about me. I've worked on, been in search for 14 years now. In fact, I met Zach, my business partner, when we were at a conference, and he was talking about taxonomy, and I was talking about search. And at the time, those were mortal enemies, right? So I've been doing this forever. If you were to ask me everything I know about search, we'd spend days listening to me bore you to death. So we don't need to know all my tacit information, but we need to know the important stuff. And we pull it out, and when we make it explicit, we want to think about that information in two styles. There's the unstructured information. It's the PowerPoints people create. It's this PowerPoint, right? It's got great information there, but there's not a lot of structure to it, right? It's even those spreadsheets. It's those long PDF files, right? The white papers that we're all reading, et cetera. It's actually, for those that were in the last session, it's the podcasts that get created, right? That's that unstructured information. But it's at least pulled out, so it's now explicit. Structured is all those things. It's the data that you have, right? So if you're doing customer relationship management, or you've got data about your procurement or any of your processes, that's really valuable information too. And you really need both. So we know how to pull it out. Now, how are we going to put it together and make use of it? And that's what some of this talk is. How do we take from tacit to explicit and then make both the structured and unstructured information work? And it's, by the way, if someone comes selling you the product that does that, run away, because there's work to do. And when we talk about the work you have to do, I think you're all going to laugh, because it's things you've been hearing all day. And it's those boring things in KM that people go, well, why do we need to do this? Guess what? It's the foundation for AI. So this is what we call our KM donut, right? It's really, for me, it's the life cycle of information. How do we go from tacit to explicit, right? We want to help people create, capture, manage, enhance. And enhance is important. How do we take that PowerPoint, that unstructured information, and add enough structure that you can do something with it, that a machine can actually make smart decisions with it. All right? How do we make it findable? And then, more importantly, and there's some neat things as we talk about knowledge graphs, and that's a lot of what we're heading to, make it so that it connects to each other, right? When we think as an individual, we think about people in relation to other people or in relation to thoughts and concepts. We need the machines to be able to do the same thing. So we have to start thinking not just about capturing information, but connecting information. So this is something you've all dealt with, right? Why KM? Now, the neat thing is when we're done this, someone's going to say, oh, why do we need a KM program? You're going to say, because you can't get to AI without it, right? But for now, think about what it does for people, right? If you can find information faster, if your life's easier, how many of you work in a large organization with tons of information? How fun is it to figure out how to do your job, right? What's that policy, right? Typically,
the right form.
Yeah, what's the right form to use, right? That's a nightmare. And it really shouldn't be if we're able to do it, if we're able to do our jobs the way we should, right? Really important that if we're able to do it. And it has huge impact. So this morning someone said, we're in the military, we don't sell anything, so why do we need KM? Right? Someone asked that question, and it wasn't quite that. It was, how do we push the value of KM since we're not selling something? The reality is, and I liked some of the answers that Bill Kaplan and others gave, if we are more efficient, if we're faster at what we do, if we know how to do things the right way, not only are the people happier that are doing their jobs, but they're doing it faster and better. So KM makes a difference. But that means let's take that tacit knowledge, let's make it explicit, and then let's make it usable, right? And we're going to talk about how we can build artificial intelligence based on that knowledge that we're pulling out. So, what are those key foundations, the 6 key foundations for getting AI in place? These look familiar to everyone? How many people heard someone talk about taxonomy these past 2 days? Right? Anyone ever done some content cleanup? Hey, that form you were looking for, is that the right version? We'll get into content types. Guess what? You can go in and clean things up. What about governance? How do we make sure that things work the right way? How do we have leadership so people follow that? And how do we create a culture where people actually look for this information? Someone in one of the sessions I was listening to said, you know, that build it and they will come doesn't work. And it doesn't, right? So how do we make it so that there's a culture there? These are all the standard things we all do in KM. And guess what? The AI piece won't work, and I'm going to walk you through why it won't. So let's start with step 1, taxonomy design. I'm going to go with the assumption that unlike other conferences I'm at, everyone here knows what taxonomy design is. It's the ability to categorize information. For machines to make proper recommendations, for machines to know what they want to tell you, they need to find why things are related to each other. Taxonomy gives you the ability to classify information so it can be shared, connected, and reused. Pretty powerful, right? So that system someone's going to buy you that's built-in AI, really? Right? Don't you think taxonomy might be a little bit important there? It makes a big difference. Content cleanup. And this is one of my favorites because it's just so obvious when you think about it. If you're asking the system to give you the answers, if I ask Alexa, right, or if I ask my phone for an answer, what if the information in it is old and inaccurate? What if the policy I ask about is last year's policy, not the new one that was just implemented this year? Right? So how good's AI going to be if I have junk content? Pretty bad, right? No chance. Computers aren't really that smart. They really aren't. They do what they're told, and if you tell them old and bad stuff, they're going to tell you old and bad stuff. That's a big deal. Yet, you know what? It's kind of painful. Who's the first in line to sign up for cleaning up their content? Anyone running to the front of the thing? Yeah. Right, it's like everyone lines up and everyone takes a step back except the poor sap that hasn't been there long enough to know differently. This is important, but it's not fun. But it's classic KM. When someone's saying to you, why do we need to do KM? Guess what? Don't clean this up. Your AI system isn't going to work. They get that when they hear that, by the way. They go, oh, yeah, that probably makes a lot of sense. How many people know what content types are? Right? It's those structured terms that define the content you're looking at. Right? So when we say we have unstructured content, in a real-world KM solution, you never have anything that's completely unstructured. You need enough descriptive information that the system can understand what it is. Because guess what? I give it this PowerPoint, it can read a bunch of words, and Pool Party and some of these other tools can actually maybe pull out some meaning for it, but they don't organize it in the great way that your taxonomy and other things allow you to organize information that aligns with your business needs. That aligns with your business. Right? Just aligned with what you have. So content types start to add that structure that allows us to really define content and allow it to talk to each other. Really important. Who here heard about the Inter-American Development Bank project? Who sat through that one where they talked about the recommendation engine that if you entered if you scheduled a meeting, it would email you in advance, here's the content you need to hear about. They couldn't do it without this. Right? They needed these content types to pull it together. They needed some level of structure to make it happen. So that's great. I've built a taxonomy. I've cleaned up my content. And I actually have content types now. I know what my content is. I can define it. Well, guess what? Maybe you're good today. What happens in a month? Right? Zach told a story to kick off this conference about how he built a taxonomy for someone, and they said, we got it. We don't need your help anymore. We don't need governance, right? And it'll be great. Well, I think he came back 6 months later, and some of the taxonomy categories were miscellaneous, MISC period, MISC, and one of the reasons I remember it was Joe's stuff, which kind of struck a chord with me. But that content governance puts us in a place where things don't fall apart, where we get rid of the duplicate content on a regular basis, where we stop it from happening. If we don't have this, right? And again, sometimes people are like, well, why do we need governance, right? If you don't have this, that huge AI initiative is just going to be a mess. Because all the things we just talked about fixing, we'll do it once, and guess what? This is great for EK. You do it once, and if you bail on content governance, you call us back in 6 months. Some ways we get more work again, but you know what? Long term, they go, why are we calling these guys every 6 months? That doesn't work either, right? So this is critical. Let's get something in place so that we can keep things in a clean place so that our computers and systems can then actually mimic artificial intelligence. Leadership. We talked about changing the culture. Culture is so critical here. That comes from leadership. Who's saying what's important? Who's saying where do we go? I loved the message that Jamie Muscoff gave earlier, where the general said, I just realized how important KM is to me, and it matters. When he said that, they were completely enabled. It became something that was important. Now, you can't always count on your leaders doing that, so you have to sell them on the idea. And it is a sales pitch, right? You've got to remind them, why is this important? Because they've got 1,000 people telling them their stuff is more important. But if they want AI, which they all do, because that's kind of cool, right? This is what they got to do to get it. So let's get leadership in place that helps encourage the other things. And then lastly, creating a knowledge-sharing culture, right? A culture where people want to share. If it's just simple top-down, you'll never create enough information for the machines to make it worthwhile. Machine learning doesn't happen with 10 documents. Machine learning happens with 10,000 or 100,000 documents. Most of these systems where we do things like auto-tagging, they give scores of how confident they are in what their tagging was, and it's typically based on how many documents they've done it against. The more the merrier, right? That's what's better. So we've got to create environments where people share. Because if they don't share their know-how, then we don't get it. It's also, you've got people in most of your organizations who are retiring soon. If they're not sharing today, and I love someone brought this up again early this morning, they said, I think it was Misha said, hey, if you try to have that 1 hour exit interview and get everything that person learned in 30 years, you've already lost, right? Let's create a culture of sharing. Let's get that information out there and use that to populate your AI engine. Now all of a sudden you can answer a lot more questions, right? You can find anything you want almost on Google. Why is that? Because there's billions and billions of pieces of information. Makes it easier in some ways. This is critical to create an environment where people are willing and able to share. Because if they're not, if you don't have this knowledge sharing culture, you also don't have people that are looking for answers that way. They're just going to keep calling each other. This is a mindset shift. So now we've set the framework. I've talked about the 6 ways that you create this. And it's all classic KM. There's nothing there that was anything you all haven't tried to do in your organization. But now, hopefully, you're walking out of here going, and I can tell them if they want AI, this is what they've got to do. So when we talk about artificial intelligence, we've been in this for a while. We got into knowledge graphs and ontologies about 2 or 3 years ago. And it was really I was looking at going, this is kind of cool stuff, right? This could solve problems. And now it's popular. Now everyone wants it, right? Facebook, LinkedIn, Google, Amazon, they're all using knowledge graphs. This is hot stuff. And so we started to say, well, what are levels of maturity around what we call knowledge artificial intelligence? There's artificial intelligence like auto-driving cars. We're not trying to do that, right? That's a little different. But we want to know, how do we share knowledge and information? And that's actually what a lot of these organizations are trying to accomplish. So I'm going to take you through these 5 areas and levels we go. So I'll let the picture get done. Everyone got their pictures done? Good. First, answer. This is kind of basic. This is what many people are doing today. And don't kid yourself, it is a form at a very remedial level of artificial intelligence. You're executing a search against a repository. How many people are doing it against SharePoint? Few, right? But whatever you're using, maybe 1 or 2, and you're getting results back. The system is making choices and doing things so that you get a reasonable search. If you have a taxonomy, you can add faceting. If you've cleaned up your content, you're not getting junk back. Right? I was just talking with a commercial customer the other day, and they're having trouble with their search. And one of the things they admitted is they have so much junk content that when they enter a search term, they get 10 results that all have the same name on it. And they said, our stats are good. 88% of the search results, people pick something on the front page. And 55% they pick the first one on the list. We should be doing really well. And I said, you should be. And then we dove a little deeper, and they said, yeah, but we have a lot of bad content. Right? Oh, I guess we're going to take a leap there and say we might know one of their problems. But this is that. I talk about chatbots. It's the basic ones. I got a question, and it basically gives me a search result. It's not going to answer a conversation. It's not Alexa, right? I was over at a friend's house the other night, and he's got Alexa set up for his lights, and we were kind of having fun in his basement because we were like, Alexa, turn lights green, turn lights yellow, and it did it, right? That's a little more than a chatbot that says, give me form whatever, which I know we want, right? Maybe that's enough to start with, but that's where a lot of people are today. So recommendations. Instead of ask and answer in a list form, now we're starting to say, I'm a little smarter about this. So now what I'm starting to do is say, I know who you are. I know what you're asking. I may even look at what you're doing and make recommendations on that, right? I'm chairing a conference in Austin, hopefully in April. We'll see what happens. And it's all about this. And we've got places like eBay and Netflix, everyone wanting to talk about their recommendation engines. This is where knowledge graphs, they're powering these recommendation engines in an exciting way. This is how you push people the information they need without them having to ask for it. Big leap, right? This is level 2, and this is where many organizations are headed. Your e-commerce places went there first because that's part of sales. And we all know if you're selling stuff and it increases revenue, you get money to do things, right? A little harder to make that ROI statement if you're not. But we want to mimic that. How do we recommend the right answers to people? And this is kind of level 2 of knowledge AI. Level 3 gets exciting. This is where you start to make answers that don't come from a single source. And your answers shouldn't always come from a single source, right? I'm working with a manufacturing organization, and they've got their PLM system that talks about their products and where things are in it, right? At the same time, they have product information, and they also have sales and customer information. And the answer I want may be a combination from all of those systems. How many people today are very good at responding to answers that come across 5 or 6 systems as a single response? Raise your hand. Anyone's organization doing that? So I need information about a product, where it is in the life cycle, and what sales are happening with that. Anyone got a place that does something like that? Well, why not? I'm serious. Isn't that the answer people want? Isn't that what people are asking for? How well are we serving our users if our system says, here's the answer from SharePoint, and I got to go to the logistics system to get this next answer. Oh, and I got to go to procurement to get this next answer. Right? We talked about efficiency back. Are we efficient? How much fun are people having? Because I bet half the time I can't log into this one, or I forget my password, or right? It's a lot of fun when you have to do that. So when you start to combine things, when you start to say I'm using more than 1 or 2 sources, and my answers aren't just the answer from this system plus the answer from this system, it's the answer that consolidates information from multiple silos. We all talk about silos in knowledge management. Now we're talking about breaking them down for real. Now this is kind of fun, and this is where, for those that study this, there's really no such thing as artificial intelligence, right? It's machines are learning and doing stuff, but they're following a set of rules. Even machine learning, if you dive into it, what they're doing is they're spotting patterns and reacting to them, right? And there's a lot of statistical algorithms and other stuff that make it look like learning, but computers, still not these, right? Faster sometimes, and better memory, especially as we get older, but not your brain. Inference is really neat. So when you talk about graph technology, and this is what these knowledge graphs are based on, you're talking about relationships. And I have kind of a neat way of thinking about this. When we were doing this for Inter-American Development Bank, they do projects in different Latin American countries, right? So if they're doing solar panels or building a bridge in one country, they have information about that. Now, in old school, prior to the ability to do inference, what you would say is, I built a bridge in Colombia, show me all the other, I'm about to build a bridge in Colombia, show me all the other places where I'm building bridges in Colombia so that I can learn from it. But wait a minute, Venezuela is right next door. It's actually very similar climate. So project information about what I built in Venezuela is probably also relevant. In a graph, you can make the inference that says, this document was tagged with Colombia. This document was tagged with Venezuela. Colombia, from my taxonomy, was identified as a country with this, this distance from the equator. Venezuela was identified as a country with this distance from the equator, so probably a similar type of environment, right? So I can now start, we talk about inference, even though these things are tagged or identified as being of different countries, we don't know they're the same. Because we know what the countries are about, a graph makes that hop, that skip or jump. We use it internally at EK to help us identify who knows what, right? So we have a graph where a consultant works on a project for a customer. If a new customer comes in, right, and that consultant worked for a customer in the insurance industry, and we get a call from a new insurance company, and we're smaller, but we're getting big enough where this becomes important. They say, who else do you have that knows insurance? Well, they don't have insurance on their resume, but because they worked on a project, and that project was for a company, and that company was insurance, I can infer that they've learned something about insurance. Does that make sense? So now, we've gone from simple question and answer to getting a little smarter with recommendations. Then we've bumped to pulling things from multiple systems. Now how cool is it, and this is where it looks like artificial intelligence, where, wow, the system was smart enough to know that Colombia and Venezuela were the same thing, or they were smart enough to know that Madison, who works at EK, worked on one insurance client, so she might be helpful with another client, right? Really interesting. So that starts to look like artificial intelligence. That's where it really starts to go, wow, this system's really making some neat choices, right? Lastly, advise. This is where you start to take all this information you have and you do some predictive analytics. Now you're writing logic. We have people that are writing R and Python to actually do classic statistical predictive modeling algorithms. But they do it better than we used to because we're not stuck with just structured data. We understand we're combining information from multiple sources, and we're able to do inference across the different hops of the relationships in the graph. Think of how powerful that is. Think of you have all that together, right? So those people that say, I want AI, I think that's kind of what they want, right? These last two. But let's go back. Without taxonomies, without content types, without content governance and content cleanup, you don't get these. These are cool things, but you don't get it. So when our leaders are all excited about that AI conference, and they come back and they say, I want one of these. Hand them this deck and say, here's how you get it. We're going to walk you through how you get there. So quickly, since we've talked about knowledge graphs, I want to explain a little bit of them to you. You may have heard it from others, so I'll keep this quick. But I'm going to give my take on it, and hopefully everyone walks out of here and goes, I know what this is. So typically, when you have a knowledge graph, you have a whole bunch of information in different locations. You define an ontology, and that sits in a graph database. So what is an ontology? Well, we just talked about it. An ontology for enterprise knowledge, a consulting firm, is I have consultants who work on projects, and those projects are for customers, right? So my ontology, as I'm modeling this organization, as I'm modeling what our organization does, I care about those things. Where do I get the customer information from? Your sales system, right? So I pull that into the graph, because the graph just does the ontology. Where do I get my employee information? Typically from our HR systems. Where do I get our project information? Well, I get that sometimes from our time and billing system, right? But I also get it from, we have little project databases that say this is what's going on. So I'm merging information, and now I can do this inference. I can start doing some really neat stuff. So a knowledge graph, you see it every day. Anyone ever seen that right-hand panel on Google? That's a knowledge graph. Google's betting their business on knowledge graphs. They really are. Search is going to be based on knowledge graphs. No question. I told you that Amazon Alexa uses knowledge graphs. And you know how I know this? Because when we were talking and blogging about this and doing stuff, I randomly got a LinkedIn post from someone who said, hey, I want to talk to you. I'm an ontologist, and I want to talk about coming to work at EK. I said, oh, this is wonderful. So I called them, because it's hard to find ontologists. I said, where do you work? Oh, I work at Amazon. And I'm thinking the recommendation engine, I buy X, get Y. And I said, so what do you do there? She said, I design the ontology and update the ontology that controls the answers you get from Amazon Alexa. I was like, oh, tell me more. How's this work? The interview went a little sideways as I started asking questions, which was kind of excited. Turned out actually we couldn't hire her because she was not a citizen, and we weren't in a position to do that. But still, it was fun to hear that that's what was happening. Since that, as I've gotten into this, LinkedIn, you know how you're connected to people? That's a graph. That's a knowledge graph. Facebook, that's a knowledge graph, right? All of your phones answering questions are sending back to a knowledge graph. Everything you're doing these days from all the super hot tech companies are doing it in knowledge graphs. And they're not impossible. They sound scary. A lot of it is the basics that we all do. You go to talk to them, your ontologists are going to talk about taxonomy. They are. They're going to go, oh, I need this, right? And they're going to say, we got to have good content. And they're going to worry about keeping it up to date. By the way, they don't have to sell governance or content cleanup because it's their lifeblood. But still, and actually, Google has thousands of people cleaning up their search stuff. They know that what's out there they're getting isn't all good. And there's still a manual process to that, right? So, but they need that to keep it clean. I'm not saying you're going to need that, right? You may, depends how bad your content is, at least for catch-up. But if you get content types and taxonomy, it gives you a fighting chance to really keep stuff clean. But this is what organizations are doing. And I love this. The application of graph processing and graph databases will grow at 100% annually till 2022. That's what Gardner said. And I actually think that's dated. I bet it's faster now. Because everyone we talk to is talking about this stuff. You know, they talk about AI, and then if you dive into people that are doing that, they're talking about graphs. So this is what it's doing. And anyone ever heard the term triple store? Did anyone use that? It's, you know how all us techie geeks use all these crazy terms that no one understands? A graph database stores three things: subject, predicate, and object. It's a triple store because it basically stores three things. What is that subject? It's Joe Hilger. Predicate, works at. Enterprise knowledge. Joe Hilger knows something about search, right? It's pretty simple. It's not that complex, but that's how we think of things. Think about that. That's how we speak too, isn't it? It's how we talk to people. It's also how you relate to people. When you're at this conference, as you spoke with someone, I bet you said to yourself, oh, so-and-so works at such and such. Oh, so-and-so knows someone else. And when you met them, did you say, like, oh, you work here, do you know so-and-so? Isn't this how we think? Isn't it kind of interesting when someone says, maybe we should store information the way we think? Now let's think more about how we store this. You have English language questions, right? You ask a question, how are you asking it? Subject, predicate, object. We did some work for a very large organization, manufacturing, that was trying to figure out, they had a data lake. They had data everywhere. And they said, our executives don't want to ask IT for a report. They want to ask Alexa and get an answer. So we built a graph pointing to all their data sets and defined them in terms that modeled the business, kind of pointed at them, because that's what graphs can do. And they said, okay, you've spent a lot of time on this. In fact, it was like a challenge as to 3 different firms to who could do it best. And the first third of the project, they're like, you guys are way behind. You're getting nowhere. These others are doing great stuff. We're like, well, be fine, right? We built our ontology. We did all that, and others were trying to do some, talking solutions. And then as we got to the end, they said, okay, but you still haven't been able to answer questions. We said, oh, that's the easy part. They said, what do you mean that's the easy part? That's the part we can't do. We said, oh, no, once the model's there, we're storing it the way you ask the questions. And then they could ask the question, who's the biggest client of our Nashville plant? And that was easy, right? Because we stored the information. We did a model that did that. We had clients, we had plants. What was really cool is they said, yeah, but we don't always call it the Nashville plant. Sometimes it's the Tennessee plant. Anyone know what a synonym is? Right? Not hard, is it? Oh my gosh, KM happening against giant data sets. That's what this allows us to do. Really kind of fun stuff. And this is a look at what these tend to look like, right? You've got your taxonomy up here with the different categories of information. You've got all the content sources, and there's your triple store. So when some tech person like me wants to intimidate everyone and says, oh, you need a triple store for that, right? Like, it's so important, blah, 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 blah. It's a database. It's kind of a little oversimplifying, but it's a database with 3 columns. But it's a totally different way to think about things. All right? So we started with KM to AI, and we really started like, you got to do the basics. And isn't that true in life, right? You know, someone does handiwork, like, you know, we had our kitchen redone, and they spend forever building the basics of it, and then all of a sudden the end happens right away because they measured right, they got all the basic material in place the right way, and it made a difference. So when we go back to, yeah, this is cool, you can show this slide to someone and say, here's your AI solution. We can do it. We can do inference. We can do recommendation engines. We can do it all, right? But at the end of the day, you can't until you clean up your mess. So some things to know about knowledge graphs, and kind of wrap up. They understand context. And this is kind of fun because we start to tag things and we recognize someone as a person, right? Remember, in our model, Joe Hilger's a person, right? So when I understand the context of something I'm looking at, think of how different that is than just searching for a piece of text. Google made this term that we all copy, because we all copy the very smart Google people. They said that knowledge graphs are about things, not strings. So it's just not a piece of text. We want to understand what it is. So when we can say something's a person, when we can say something's a project, that starts to matter. Now, all of a sudden, we can give information in a very meaningful way. Natural language search. Those subject, predicate, objects certainly work well towards natural language search. And our taxonomies. All the stuff that we do in basics that we KMers get. All these people now are like, oh, we want AI. KM's dead or old, right? Guess what? We're your path. You got to go through us. And you got to do it the right way for once, because sometimes they don't listen, right? Structured and unstructured information. We talked about this. I can pull information from multiple systems and point to it. One of the things that's been fun for us is we get 2 very different types of calls. We get organizations that call us up and say, we've got a mess of data. Could you figure out how to bring that together? And then we get other organizations that say, we've got all this content and we don't know how to pull that together. We do both those separately, but then we also go, hey, why don't you do it together? Because the graph points at something. It doesn't care. It doesn't care what the structure is. It's got its own. It's saying, hey, this table in this field is related to this field in this table. And oh, they're related to this document that describes the table. Oh my gosh, we just broke down barriers. How many times, how long have we all been trying to solve the structured and unstructured problem? Anyone struggle with that? Guess what? We finally got a tool that does it. And then aggregation. You build a model that designs how people think and work, and it makes it a lot easier to pull it together because you're pulling it together in a meaningful way with information that makes sense. Does that make sense? Go with a yes. Wonderful. So how do we get started? Your company said, I want AI. As a KM champion and leader, your job is to get them excited about AI. Oh yeah, let's do it. And then, take them down that path, draw them in, and then come back and say, and guess how we do it? Here's the steps it takes to get this right. And you all heard this. When I described this, wasn't it all kind of obvious? Right? Hey, we got to clean up our old content. This stuff, when you get them talking about what they're excited about, and then you show them the roadmap to get there, it's going to encourage your KM initiatives, because this is what you're trying to do anyway. Look at the products and tools that can help automate information management. Guess what? You're not going to be able to tag 1 million pieces of content. Pool Party, who was at the conference here, not only can, kind of wants to, right? And they're not the only one. There's a lot of systems that will do this. So look around. For any of you in the government, I know it's hard to do a new procurement, but guess what? From my experience working with different agencies, you probably own most of the stuff you need. You just got to find out where it is and who has it. So look around. Get educated on what's out there. Ask an expert. And find out what you have that you can start automating your information management process. You can't do this manually. So let's see what's there. But you don't have to buy a new one in many cases. And if you do, if you've made the case, everyone's going to want to buy something for AI. You just got to make sure you're doing the automation of the information management so that the AI works. And start to understand what you have. I gave a couple of examples, right? I talked about at EK the different systems we pull from. Well, that's us. What's your environment? What information do you have? Because we can't do content cleanup if we don't know what information repositories we have. And when we talk about stitching things together, don't you want to know what you're stitching together? Right? You don't have to inventory every single document, but you certainly ought to at a high level know, I've got invoices here, I've got this information here, and guess what? It's not just all about documents anymore. It might be, I have customer information here, I have base information here, right? What do I have, and where is it, and how accurate is it? And then start small. This stuff maybe sounds simple when you start, oh, look at how we pull it together, I describe people, etc. Don't boil the ocean. And we've all learned this. Anyone that's done systems work before or anything like this, you can't. Pick a specific use case, get started and say, this is the problem we're going to solve today, and we're going to prove it. And once we solve that problem, then we're going to solve the next one, and then the next one. And it is so neat, because once you solve one or two, once you get a little momentum rolling, it's that flywheel. It gets rolling down the hill. And all of a sudden, everyone wants it. We had a project where we did something similar like this for a large civilian agency. And we worked with the first two groups, and they became our biggest advocates. And before we knew it, we had another problem. We had 40 projects queued up, and everyone was arguing over who was next. That's fun. It's kind of stressful the other way. But it's at least the right thing. Isn't that a lot better than being, oh, I got nothing, I'm pushing a rock uphill and it's just coming down, right? So use AI to your advantage, but then get some small wins. Because if you try to go too big, number one, this stuff gets complex, and you're going to mess up, and maybe your recommendations aren't going to make sense. Pick something small, get it done, and then start to grow it. The nice thing about graph databases as opposed to relational databases is they're easy to change. I don't have to add a new column or a new table, right? All I have to do is add a new relationship. And I'm not moving data, so I just point to it where it is. So it's not as hard. Gives you a better chance. So start small and then grow. That's it. I don't know how long. Usually I go, oh, I kept it short. So does anyone have questions, or do you all want to just get on the road and get out of here after 2 long days?
Joe, I appreciate the brief. You talked about content cleanup. So when folks say, I don't have the time to do this, sometimes it's a legitimate concern. So you mentioned automation, which might be the answer, but what's one way to get after content cleanup?
Yeah, I'll tell you, it's kind of daunting to say, how do I find duplicates of content, right? Because you know you have it. One of the things we do is we don't usually do content cleanup first. We do taxonomy first. Then we look for an auto-tagging solution. Then all of a sudden, we can start saying, here's this category. I can filter to these sets of documents. And instead of looking at a corpus of 100,000 documents, show me the procurement forms. Oh, wow, there's 20 of these. Delete these 6. Right? That makes the job at least seem possible. Right? So that's where I said go back to automate information. There's some other tricks you can do. Some search engines can actually do. They can look at documents and actually theoretically, statistically say these are statistically close enough that they're similar. I don't love that as an answer, because you still then have to, I mean, it's a starting point, but you still have to do the research to say, well, which is the newer one? And why did they change? So I think the taxonomy is an easier way to do that, but there are multiple ways to automate it. And again, you do want to look for some automation, because it's hard. You just can't do it. I don't want to print something out, 1,000 documents and check it off. So, yes?
I've done a lot of work on concept mapping.
Yeah.
And when I see a knowledge graph, it's essentially a very simple concept map. So I'm looking forward to when the AI is even more sophisticated and you give the AI a complex concept map, and you actually be able to map all of this there will still be a human creating the map, essentially creating the model,
Yes.
and then connecting all of the.
Isn't that cool? The ontology is the model. It's how things fit together. And a human can do that. You can't do that. You can't look at 1 million documents at scale, but you can create a map. What I would say to you is, I don't know that that's not all already possible, right? These triples, depending on how big they can get, can perform pretty well. We never start with a complex one. You start with a simple one. Because, countries and attributes about countries, that's a pretty important thing, and maybe types of projects, topics, or maybe an easy start, or people, projects, companies, right? Think of all we can do with just those 3 simple things. But you're right, keep adding, and here's the neat thing. As you add new items to your concept map, or to your ontology, it's just new rows in a triple store. Not hard to change, so start small. Don't throw the whole big thing in there. Someone's head's gonna go crazy. But yes, you can definitely go that way. Anyone else?
So I'll tell you that at least what we're seeing in the DoD specifically, but I think it's a federal government mandate, is that the chief data officers are the ones that are really taking ownership of this aspect.
Yeah.
But what we found at our command is that the guys that were responsible for trying to take that on are desperate and go, KM, what should we do?
Well,
so that's a good thing.
Absolutely.
The model you're talking about.
And so I'm speaking in 2 months. Again, fingers crossed these days. I was asked to speak at one of the data conferences. Because what the data people are realizing, everyone built data lakes, right? I've got it all on one platform. I've got this great data lake. And then someone goes, well, what's in it? What do I have? How does this fit together? For the Federal Reserve Board, what we did is we built a model that said, this is what this is. And imagine, so people used to do, old school, you would do kind of a data dictionary that said, here's the field name, but it didn't mean anything. Federal Reserve Board had tens of thousands of data files, but they didn't know what was where and what happened and how to do it. So we started to say, these are the models, and we're pointing to fields or tables or files, and actually making that look like the business. So what's neat about this is, not only is the KM kind of more historically the unstructured world coming around to this, and it's interesting, government's behind, commercials all over this, in this space. All the data people are going, oh, we need a knowledge graph to model this. There's a Data.World is one of the leaders in this, and they talk about they're revolutionizing the the old school data dictionary, by building it as a graph and talking about relationships between data elements and how they fit together. And what you're going to find, if your people are going to data conferences, they're invited to KM or to a data conference, like you said, because guess what? Metadata and knowledge graphs are what solves their data problem. So absolutely, and won't that be wonderful when they do that? Because then content fits there too. It's all about metadata, taxonomy.
I'm seeing data management is essentially replacing the word knowledge management with data.
Yeah.
So as they start to dig into it, they're just doing knowledge management. They don't realize it.
Yep.
So we can walk in and start to talk some really incredible things, and their eyes just sort of glaze over. It's like, oh my God, how do you know all this?
It's old school. Isn't that fun? Well, shouldn't it be? Like, when we talk about knowledge management, why have we decided it's just documents? Knowledge is information, right? Knowledge is, it's those spreadsheets, those databases have knowledge. Why aren't we using that? We didn't before because we didn't have the tools or technology. What I'm telling you, we now have the technology. We don't all know it yet, but we're going to get there. Any other questions? Great.
Thank you.
Wonderful.